So we'll start by looking at general equations for tangent and cotangent functions today. And we are not going to worry necessarily about this bx minus c. We'll talk about it, but I tell you, for tangent, cotangent, I won't give you any horizontal shifts. What I will do is this. I will tell you the period. The period is how often it repeats itself, okay? And the period is pi divided by b, the value in front of x. How is that different from what we've done earlier? Yeah, it used to be 2 pi. Let's talk about that difference. Why it's pi and why it's 2 pi. If I look at my quadrants, this is 0, this is pi, this is 2 pi. So 2 pi is 360 degrees all the way around, right? Whereas pi is just 180 degrees. Here's why it works like that. Sine is positive here, negative here, negative here. So how many quadrants does it take for sine to go through its complete cycle? It takes 4 quadrants, right? It's got to get through its positives, it's got to get through its negatives. Tangent is positive here, negative here, positive here, negative here. So how many quadrants does it take to get through its cycle? It just takes 2. It just cycles through 1 positive and 1 negative. It just repeats itself down in the 3rd and 4th quadrant. So therefore, tangent repeats itself instead of through 4 quadrants, it repeats itself through 2 quadrants. And you can see 2 quadrants is just a value of pi, 180 degrees. So that's why it's not 2 pi, it's just pi. Yes. So on your sheet, I have that listed for you. Your sine and cosine is 2 pi divided by b. Your tangent and cotangent is pi divided by b. Everybody got that? So we move on from the period to the next piece. And, okay, and horizontal shift, solve bx minus c is equal to 0, okay? And we won't even do that, okay? We're just not going to make that a part of what we're going to do. We're just going to focus really on the period, and we're going to focus on the direction. It is not the amplitude. Sine and cosine are waves, so they have an amplitude. Tangent's not going to make a wave. So you don't really need to worry about A other than this. Look to see if it's positive or negative. If it's positive, it will follow the parent function. If it's negative, it will make a vertical flip. Okay? Everybody got that? Okay. Now, trust me, these are not difficult to get through, but it's challenging to think about them right away. The period is pi divided by the number in front of x. So pi. Because it only takes 2 quadrants to repeat itself, I will mark out pi and I will divide it in half just once. You see that? I marked out pi, and I divided it in half once. So I have 2 intervals because it repeats itself in 2 quadrants. Now, let's think about some special values for tangent. Don't have to write this down, but think through it. On the unit circle, what is that point? What is that location right there? 1, 0. What's this one? 0, 1. This one? Negative 1, 0. And this one? 0, negative 1. Everybody okay with that? In terms of x and y, what's tangent? Tangent's y divided by x, right? So let's think about it. If you take y and divide it by x, does anybody know what 0 over 1 is? It's 0. Do you know what 1 divided by 0 is? undefined. Do you know what 0 divided by negative 1 is? 0. If 0 is on the top, it is 0. If 0 is on the bottom, it is undefined. Now, these are important spots for us to figure out, okay? This is 0. This is pi over 2. And this is pi. So think about those values. Let's start to plot them on our graph. Trust me, you don't have to do this kind of work every single time. I'm just trying to explain it to you, okay? What was the tangent of 0? What did we get? Remember that first value? We got 0. Do you remember the tangent of pi over 2? It was undefined. Do you remember the tangent of pi? It was 0. This thing in the middle is new to you. You haven't seen it before. It's called a vertical asymptote. An asymptote is an imaginary line that the graph approaches but never touches. Anytime you have an undefined value for tangent or cotangent, you will draw a vertical asymptote. So if we look back at this piece right here, remember 0 degrees gave us 0. Pi over 2 gave us undefined. Pi gave us 0. What would negative pi over 2 give us? Undefined. What would negative pi give us? 0. So as we go back to our drawing, you can see that negative pi over 2, you said, gives us an undefined value, and negative pi gives us 0. We're almost done thinking through tangent. Trust me, you'll feel better after we go through some examples. Okay? But I'm going to move just to this side. Everybody agree that I'm just a little bit past 0 here? Tangent is y divided by x. Does that sound similar to something else you've used over the course of your mathematics career? It sounds similar to slope. Rise over run. Tangent just measures slope. You guys tell me, if I increase my degree from 0 to just like a little bit, like 1 here, do I have a really, really big slope or really, really small slope? Really small slope, right? How about as I get close to pi over 2? Am I going to have a really, really big slope or a really, really small slope? Really, really big slope. So what we do is as we get close to pi over 2, we have really big values. As we get close to 0, we have really, really small values. And this is the type of curve that it generates. So this is the tangent curve. This is your parent function for the tangent curve. Let's flip the page over so we can mark how to graph this. Important parts of the tangent graph are the asymptotes. An asymptote is an imaginary line the graph approaches but does not touch. It's an imaginary line that the graph approaches but does not touch. So we draw it on our graph in order to kind of have a curve or a guideline for how to sketch our graph. But it isn't actually part of the graph. If we looked back at the graph we just generated, we got I'll flip mine. You guys don't have to flip yours. You see where tangent is equal to 0? Right at these spots? See that? So I'm going to write those down. Tangent is equal to 0 for values like negative pi, 0, pi. It would actually also work out for 2 pi, 3 pi, so on and so forth. Do you remember what the period was? Pi. Look at where it's equal to 0. Every pi units, right? So here's what's interesting. This is super important. Tangent of x is equal to 0 at period values. So whenever we mark out the period, that's where tangent goes through the x-axis. Look at my graph. How would you describe to somebody where tangent is undefined? The period is where I put the dots. It's undefined. Halfway in between, right? So that's all we have to do. We just mark the zeros at the period, and then we draw vertical asymptotes halfway in between. That's it. Tangent of x is undefined, halfway in between periods. It's probably the easiest way to think about algebra. So let's try an example before we do tangent, or before we do cotangent. Okay. We'll flip over to this page, and we'll try graphing the very first one. We'll try graphing letter A. Y equals tangent of pi x. I start by identifying the period. In order to find the period, I take pi and I divide it by the b value. What is the value in front of x? Pi. What is pi divided by pi? 1. So I mark 1 unit on each side. That is where tangent will cross through. How many quadrants does it take for tangent to repeat itself? Not 4, but just 2. So I divide it in half. I know that tangent is equal to 0 at negative 1, at 0, and at 1. Where will it be undefined? Halfway in between. In order to show it's undefined, I draw vertical asymptotes. What does the tangent graph look like? Does it start down and finish up? Does it start up and finish down? They start down and they finish up, right? So that's just what we draw. Not too bad, huh? Mark the period. Asymptotes halfway in between. Draw the graph. Let's try a cotangent one. Let's think about cotangent. Can somebody tell me what's the difference between tangent and cotangent? Or rather, how are they similar? Yeah, they're reciprocals. Tangent is 1 over cotangent, and cotangent is 1 over tangent, right? You just flip them upside down, right? Okay. So we're going to do the same thing. We'll start out with the period is equal to pi divided by the number in front of x. What's the number in front of x? 1. So I get pi. I'm going to mark out pi. How many quadrants does it take for cotangent to repeat itself? 2. So I divide it in half. Are you okay there? Now, here's the last part of the day that you really have to put your thinking cap on for. What is the height of tangent right here? 0. Would everybody agree that that's 0? Okay. We can use that to think about the cotangent graph. The cotangent value would be the reciprocal of that, right? What's the reciprocal of 0 over 1? 1 over 0, which is undefined. So instead of crossing through 0, it's undefined. Can somebody else tell me where else would it be undefined? 0. Where else? Pi. So let's make a conjecture. Tangent is equal to 0 at the period. Cotangent is what at the period? Undefined at the period. See the difference? Tangent is equal to 0 at the period. Cotangent is undefined at the period. Let's look at our next values. Would everybody agree that tangent does not have a value at negative pi over 2, that it's undefined? Everybody agree that 1 over 0 is undefined? So if cotangent is the reciprocal, what's the reciprocal of 1 over 0? 0. So therefore, it's going to cross through right there. Now we think we kind of got it figured out, but there's one last little change here, okay? Let's look at right here. I'm just going to go to this spot, okay, this spot on the graph, just to the side of 0. Is that a really, really big value or really, really small value? A really, really small value, like say 1 over 100 or something, right? What happens if I take the reciprocal of really, really small values? You get really big values, right? So if I go just to the side of 0, I'm not going to get a really small value. I'm going to get a really big value. So the cotangent graph actually starts up and finishes down due to that characteristic. So let's flip over here, make sure that we write this down. Tangent and cotangent are reciprocals. So if they're reciprocals, what's the reciprocal of 0? Undefined. So therefore, cotangent of x will be undefined at period values. What's the reciprocal of undefined? 0. So yep, that's where you get your vertical asymptotes. That kind of connect a little bit? So let's try a cotangent graph together. Try letter C. I'm going to calculate the period. I will take pi divided by the number in front of x. Kind of tricky. What's the number in front of x? 1/4, right? I don't like to divide by fractions. So what should I do instead? What's the reciprocal of 1/4 times 4? So I get 4 pi. So that's my period. So I mark out 4 pi. And negative 4 pi. How many quadrants should I divide it into? 2. Hey, I'm doing cotangent. Is cotangent equal to 0 at the period, or is it undefined at the period? Undefined at the period. Well, my period value is every 4 pi. So every 4 pi units, I'm going to draw vertical asymptotes because it's undefined. So if it's undefined there, what happens halfway in between? It's equal to 0. It crosses over the x-axis. Does cotangent start down and finish up, or does it start up and finish down? It starts up and finishes down. Let's go back to a tangent graph. Negative 2 tangent of x. Period will be pi divided by, what's the number in front of x? 1. So we get pi. So I mark off pi. How many quadrants do I divide it into? 2. And now I answer that big question. Is tangent equal to 0 at the period, or is it undefined at the period? It's equal to 0 at the period. So every period value, I will put a dot where it crosses. Somebody tell me something else intelligent about the graph. What else do I have to mark? The asymptotes will happen halfway in between. Does the graph of tangent start down and finish up, start up and finish down? Start down and finish up. But there's a negative sign. So that's going to make it start up and finish down. Everybody see that negative 2 in front there? I don't want you to worry about the fact that it's a 2. It could be a 4. It could be an 8. I don't care. What I want you to focus on is that it's negative. If you want to know what to do with it because it's a negative 2, technically the slope of your line should be negative 2 as you're going through that point. Okay? But I'm not going to be checking for that to make sure you have a perfect slope. It just means that it's kind of steeper through there. Let's do the last one, letter D. I'm going to start by finding my period. For my period, I take 2 pi and I divide it by b. What is the value in front of x? Pi over 3. So I will multiply by the reciprocal. Well, I'm sorry. Thank you. I ate a bowl of stupid for breakfast. Pi divided by pi over 3. So I will take pi over 1 and multiply by 3 over pi. Right? What happens? And I'm left with 3. So 3 is my period. How many quadrants do I divide it into? 2. Tangent, cotangent are broken into 2 quadrants. All all the others are broken into 4. Yeah, we'll go back. Okay, I've got that. You tell me, is cotangent equal to 0 at the period, or is it undefined at the period? So I draw vertical asymptotes at the period. Notice we always include 0 as one of those period values. What happens halfway in between? Crosses over 0. Will cotangent start down and finish up, or start up and finish down? It starts up and finishes down, but this one, because it's negative, will start down and will finish up. If you look at your cotangent graph that we had for your parent function right here, you see cotangent starts up and finishes down. Because of the negative sign in front, it will start down and finish up. Okay. All right. Not too bad once we got rolling, huh? First 10 minutes is like trying to figure it out, but once you do this piece, I will tell you, I think that as you get going, this is kind of the nice problem. You don't have to worry about 4 shifts. You just kind of got to worry about 2 things. Number 1, the period, and then where to draw your asymptotes. So I think you can do that. Let me pull up the assignment. Okay, so there's the book assignment that follows off with our follows from our calendar right here that we did back first semester. So there you go. And just a couple more assignments, and we'll be ready to work towards tests. There you go.